alert.
Welcome class 10 to the rapid revision series day 1. We are starting with the chapter carbon and its compound. So starting the topic with covalent bond. Covalent bond are those bonds which are formed between the two atoms by the mutual sharing of their valence electron. Bond formed between two atoms by mutual sharing of their valence electron. Here are some example, like we can see the formation of covalent bond. First is for hydrogen molecule. As you know, hydrogen symbol is H and there is one valence electron, the second valence electron. A bond between H and H is formed by the mutual sharing. These electrons are the shared electrons. Take another example of a molecule like NH3. A nitrogen has 5 valence electron plus 3 into hydrogens. Now a bond is formed as now for nitrogen we have 1 2 3 4 5 6 7 8 electrons. So next we are moving to the characteristics of covalent bond. So first characteristic, that the bond formed within the molecules are strong, but the intermolecular forces of attraction are very small. That results in low boiling point and melting point. The second characteristic is these are poor conductors of electricity and heat. Next we are seeing the term covalency. What is covalency? Covalency is the number of electrons contributed by each atom for sharing of we will discuss the covalent nature of carbon. So the first question that arises in our mind is that why carbon forms covalent bond. So the answer is that, as you know, there are four electrons in the outermost shell. Like if we see the configuration of carbon, the atomic number of carbon is 6 and the shell configuration are 2 and 4. Here are 4 electron will be needed to make this a stable configuration. Now for making a stable configuration, we have two ways. First is we can remove 4 electrons and make it like a helium like helium and having a atomic number 2 and a 2 electrons stable configuration. But um, removing 4 electrons and making C4 positive, the compound formed is not stable here. The reason for this is because the reason behind this is there will be higher energy required. Higher energy will be required to remove 4 electrons. That's why the carbon atom will get unstable. Now second case is we can take 4 electrons, like we can add 4 electrons. So to add 4 electrons, we get a species like this, and it will be having a configuration of neon. That is another stable atom. Now to add 4 electrons, we require large amount of energy. To overcome the forces of repulsion between 4 electrons in carbon atom. So these are the two reasons why a carbon do not form an ionic bond, why only the covalent bond is formed here. Now what is the second question, why in such cases what will carbon do? So the answer is carbon will form a covalent bond. To overcome these limitations or problem, it forms covalent bond. Second is the allotropes of carbon. There are 3 allotropes of carbon. First is graphite, second diamond, and third is Buckminster fluorine. These are the 3 isotopes of carbon. Diamond, each carbon is bonded to the 4 other carbon. Each carbon bonded to other 4 carbon. in tetrahedral geometry. Like these, the bonds are formed. Now, as you can see, there is no valence electron in it. Thus, carbon allotrope diamond is poor conductor of electricity. As the structure is closely packed and each carbon is connected to the other four carbons, so this makes the structure hard. The second allotrope is graphite. In graphite, each carbon atom is bonded to three carbon atoms in a hexagonal packing like this. These hexagonal packing is formed in a form of layer. As you can see, there is one valence electron at each carbon atom, thus it will conduct electricity. And since these are formed in a layer form, thus the layer can be easily sliding over each other, making it best for grease that we can use in machineries. And the third isotope is fluorine, Buckminster fluorine. That is another class of carbon allotropes consisting of C60 carbon atoms, which are arranged in a football shape. Next comes the versatile nature. Like we are studying, there are 118 elements in our periodic table, and oxygen being the most important for us, but still we are going to study carbon. Then this is because everything around us is present mainly because of carbon. So what is the reason this versatile nature of carbon? So there are two reasons for these versatile nature of carbon. First is catenation. Second is tetravalency. Catenation means self-linking power. Carbon can form bond with the other carbon very easily. Even it can form the multiple bonds also. The second reason is tetravalency. That means a valency of 4. So tetracovalency means that carbon is capable of forming 4 bonds with the other monovalent atoms or any divalent atom. The these two reason makes carbon versatile in our nature. Now next we move. This is a basic about carbon. Next we are going to cover the topic of hydrocarbons, the most important and most asked question in paper is from the hydrocarbons. The hydrocarbons are the compound which is formed by bonding between carbon and hydrogen. So there are two classes we have to study. First is saturated and second one is unsaturated. Saturated carbons means which only have single bond, which have single bond. Unsaturated means which have multiple bond between carbon. This single bond would be between carbon and carbon. See, you can learn it like saturated, S4 saturated, S4 single. Next, there are some functional groups. So I will be naming the functional group. Like there will be some heteroatom. Hetero means different atom from the carbon is present in the organic compound, that is known as functional group. The first group functional group, and here we'll be naming the suffix, that is secondary suffix. The first functional groups is halo group. Here we have a halogen family like fluorine, chlorine, bromine, iodine. For this we use secondary, here we use a prefix halo in front of the compound. Like if we have a chlorine attached to our hydrocarbon, then we will naming it as CHLO, chloro. If fluorine, then fluoro. If iodine, then iodo. And if there is bromine, then bromo. Second functional group is alcohol. The functional group here is OH. If we have OH at the end of any carbon or organic compound, then we will be belonging to the alcoholic group, and we will use a secondary suffix for these alcohol as OL. The third group is aldehyde. Functional group is CHO, like a C attached to double bond O and a hydrogen. The secondary suffix we use here is Al. Third is ketone, C double bond O, and we have a C double bond O between two carbons. We will use a secondary suffix ONE for representing secondary suffix will be ONE. The next is carboxylic. It is C double bond O OH. We will use a suffix here like oic acid. So here is a brief about these group. Now I will tell you the IUPAC naming. IUPAC stands for International Union of Pure and Applied Chemistry. So we will complete the basic in this IUPAC in this video. For next video we will start with the some example of IUPAC naming, or we can say the nomenclature and some chemical properties. So the basic for IUPAC naming or nomenclature is that we have to use a word root, then a primary suffix, then secondary suffix, and for some compounds we will use some prefix. Generally we use prefix as a Arabic number like 1 2 3 to tell the position of functional group, or for halogens. So word root stands for number of carbon in organic compound. Primary suffix tells about type of bond. Type of bond. If carbon carbon has single bond, then we use primary suffix as "ane". If carbon double bond carbon, then "ene", and if carbon triple bond carbon, then "ine". And for secondary suffix we use functional group. Thank you for watching. In next class we will do some example, and we will cover some important topics of this chapter.
Thank you.